Question number 61. Consider the following reaction. We have this given reaction in which the substrate is the derivative of phenol, and there is a two-step reaction that's taking place. And there is the product P. That's a major product we have to find out. So in this case, first let's draw here the substrate that is the derivative of phenol, which has the substituent present here. Now, in the first step, there's the attack of alkali, and this alkali will extract its acidic proton because phenol is there. So phenolic proton would be lost from here to form phenoxide ion. So the phenoxide ion that would be formed here is this, and this substituent remain intact. Now, the second reagent is there. Now this is substituted benzene that you're just going to use as the reagent here. Further, in this case, the reaction will take place in this manner, and the product formed is this would be there, and this is the product. Along with that, HBr is also formed. So what is the product in this case? This one. And on that basis, we can easily choose option 2 as the correct option because this is given in option 2. And the answer for this question is option 2. Now let's take next question. Question number 62. The intermediate product formed in Riemer-Tiemann reaction is. It's a simple question based on the name reaction, that's Riemer-Tiemann reaction, and we need to find out the intermediate product formed here. Now first I just want to show you here that what is this Riemer-Tiemann reaction. We know that the substrate is phenol here, and during this Riemer-Tiemann reaction we form salicylaldehyde from phenol. So how would this reaction take place? In this case, first this NaOH is there and chloroform is also there. What is the attacking species here? That's an electrophile that's here is CCl2. This is the electrophile that's taking part in this reaction, and first this OH gets changed into ONA due to the attack of this NaOH, and here is CHCl2 that is formed. Further, this NaOH react with this product. This is the intermediate product formed, and here is the formation of sodium salicylate. Further, in acidic medium, the final product that you will obtain is salicylaldehyde. Now, in this case, this is the product that is intermediate. And if it is the intermediate product, we need to just check where it is present in the given options. In the given options, it is present in option 3. So that's why this option 3 is the correct option, and I'll choose it here. Now, after this, question number 63. Question number 63. When anisole is treated with one equivalent of HI, the product formed R. So in this case, the reagent is HI. So we have the two species here, and anisole, that's an ether. In the first step, there's the attack of this H plus ion and the formation of the product that is intermediate is OH CH3. This is highly unstable species, and here this I negative iodide ion will also attack over here, and here this iodide ion will react with this. Basically it is the SN2 reaction that's taking place, and ultimately the product formed would be phenol from here, and along with that methyl iodide is formed, and these are the products which we need here. So these products are given in option 3, and that's why I'll choose here option 3 as the correct option. Now after this, let's move on to the next question. Question number 64. When acetophenone is treated with hydrogen, followed by heating with sodium hydroxide in the presence of ethylene glycol, then the end product formed is. You have the substrate, you have the reagent, just identify which reaction it is. This reaction is Wolff-Kishner reduction. The reagents which we are using here, hydrogen, followed by sodium hydroxide in the presence of ethylene glycol. These are the reagent which we are using. And what is the substrate that we are taking here? The substrate is acetophenone. So that acetophenone is this. Now after this reaction, the formed product is ethyl benzene. And where this ethyl benzene is given, just have a look on the given options. You will identify it is given in option 2. This is basically ethyl benzene. And that's why the answer for this question is option 2. Now after this, let's check the next question. Question number 65. A carbonyl compound reacts with hydrogen cyanide to form cyanohydrin, which on hydrolysis forms a racemic mixture of alpha hydroxy acid. The carbonyl compound is. It means this is a two-step reaction. The first step is the reaction of the carbonyl compound with HCN to form cyanohydrin. And that cyanohydrin, when hydrolyzed, it forms racemic mixture of alpha hydroxy acid. It means if you want to obtain the racemic mixture of alpha hydroxy acid from cyanohydrin, it means cyanohydrin should also be there in the form of racemic mixture. And if you consider this benzaldehyde when reacts with HCN, it forms the racemic mixture of cyanohydrin. Actually, it is forming and another one is this. Another isomer that would be formed here. This one. And this is the racemic mixture of these two cyanohydrins. Now, if this is hydrolyzed, it will form the racemic mixture of alpha hydroxy acid. Definitely on hydrolysis, the products formed would be alpha hydroxy carboxylic acid. These two products would be formed. This is also the racemic mixture. So benzaldehyde is doing so. But if we talk about the other compounds, they will not do so. That is why I'll mark it as the correct option. So the answer for this question is option 2. I hope this question is clear to you.